Okay, so here it starts. 1 through 6 I've decided to skip because I'm pretty sure you guys know how to do that. Those are easy questions. Those go back to Algebra 1. So I'm going to start with number 7. This is what I probably have the most questions on. Number 7 and 8, these guys are what's called the remainder theorem. Alright, so the remainder theorem, and I pretty much talked to a lot of you about this, but this is basically synthetic division. Alright, the remainder theorem says that when I apply the exact number, it's right here, okay, when I apply this exact number here, okay, when x equals 2, when I put 2 in the window, I'm actually evaluating it. It's going to go into this x each time. So if you remember the way that synthetic division works, when you drop down this 1 to the bottom, like you're going to be multiplying by 2 several times, and that multiplication of 2 happens right here. Alright, so you could actually kind of, think about, well, what are you doing in synthetic division? And when you do it, you are doing this right here. You are putting 2 in for x. Alright, now I won't go into it right now just because we've got a lot of work to do, but just synthetic division does do that. So I need to go back there and I need to write down that problem. So x to the third power, it's just a 1 for the coefficient. Then I do not have an x squared, so I do need to put a 0. Then I have a -3, and then I have a 10. Okay, so a lot of you probably, your first time around, probably forgot to put that 0 there. So just remember, this is the x to the third, that's the x squared, and there is no x squared, so we have to put a 0 there. This is the x, and then the 10 is for the constant at the end of the polynomial. So when you drop down the 1, okay, 2 gets multiplied to the 1 and then bounces up here so that it gets added downwards. Alright, you're adding going down. Alright, and then 2 gets multiplied to the 4. Okay, that's not to the 4. 2 gets multiplied to the 2, it becomes 4. Add 1 through 2. Okay, when I add those 2, it's 12. So this means that 1, 2, 3. I multiplied 2 3 times. Alright, and I added -3 plus the 2, right? That was, so it works out. Okay, it works out. So don't change the sign when you want to evaluate. Okay, don't change the sign. The only time you change the sign is if you had an x, say x plus 4 that you were dividing by, then you want to put a -4 in the window. See, this is different. This is, you're dividing a binomial into it. Alright, you're dividing a binomial into the actual polynomial. This is just, you are just plugging a number in. Okay, so 12 is your answer for that one. Number 8. Number 8 is, okay, so -3 goes in the window. I have a 1, a 4, a 7, a 14, and a 16. Okay, so that is the polynomial there. I'm going to drop, and I'm just going to go through the motions here. -3 times 1 is -3. Drop that. 4, -12. Add that. That's +2. -6, and I get a +10. Alright, and I will just double check that. I feel like I did it a little fast, and that's A. So 7 is C, and 8 is A. Alright. Okay, so that's 8. We'll do number 9. Gonna chug right along here. Number 9. I wish I had a hard copy here. My printer is at school. Okay, so now with this case, what we've got is we have the end behavior. Alright, now this is going to go pretty quick because there's only 4 possibilities. I mean, when you look at this, you think that there's more possibilities, but there's not. There's only 4, and there's only could be 4. Okay. Now I know you can't see my finger pointing at it. All right. So let me do this. The x, as x goes to -infinity, and as x goes to +infinity, these are always going to be there, because it's a left, right, left, right, left, right, left, right. You always have 2 arrows when you're dealing with you're either increasing or decreasing, or the arrows are going to tend towards increasing or decreasing. So you want to know, is the arrow pointing up or down? So this f of x represents the up or the down. Remember, f of x is just synonymous with y, the y coordinate. So as x is going to the left here, is f of x going to negative infinity? Is it pointing down? Okay, so A would look like this. Okay, so negative infinity. B, I know you can't see this, but just a second. What I'm doing is I'm drawing the arrows for each possibility here, okay, in order. Whoops. Okay. Okay, so let me just jotted that down. This is your A, B, C, and D. All right, these are the only 4 possibilities you have for 2 arrows when the arrows either point up or point down. So this means that this would have to be a positive odd. Why do I know that? Because I memorized the chart. All right. This means that you start off negatively, and as you move to the right, you're going to end up going upwards. Here, they're both going down. Here, you start up and then decrease through the whole interval, fundamentally. And then these guys are both going up. So which one is it? Well, it's the one. Well, that is a positive even. I don't care about any other term except this guy. That leading coefficient is a positive 1, and this exponent is a 4. All right, so that 4 means it's even, and this is a positive coefficient. So this means that is a positive even, and the only one that is positive even is this guy. That's a positive even. Okay, this would be a negative even because they're both going down, and this is a negative odd because he starts up and then goes down. This guy starts down and then goes up. So that's it. I mean, you just have to remember the chart. Okay, so that when we go to number 10, we can see here that we have a positive coefficient 1 and we have an odd degree of 5. I don't care about these terms at all. I just want to know this because he's the dominant one. Okay, he's the dominant degree, and he dictates the behavior in the long run. Okay, these guys are more short run, like what happens in between, but this guy determines the end behavior in the long run. So at a positive even, that would be, positive even is this guy. I said even, I meant odd. I think I said even like 3 times. It's a positive odd because 5 is odd. So it means then that I'm looking for this. So the way that I interpret this then is f of x is going towards, okay, I start with the left, it's going downwards, so he's going to negative infinity as x is going to the left. Okay, then this guy is going, this here is going upwards as x is going to the right. Alright, so I just have to find that guy. So again, this is down, this is up, this is left, that's right. Okay, just keep thinking about negative and positive infinities. You'll be fine. All right, so that's number 10. So what was that? Negative. That would have been negative. That would have been C. All right, so it's C. Okay. Oh boy, I'm tired. I don't know how many I'm going to be able to do. Quite frankly, I can do more over the weekend. Anyway, it's better that you guys work on this and kind of push through on your own before you know the answers. It doesn't help too much to do that. Where'd it go? Oh, it's here. Okay. All right. So, this guy, number 11. 11, is it a factor? Okay, well, that means we use the factor theorem. And let me set up my problem while I'm looking at it here. We've got 6, 12, negative 23, negative 15, all in order. Okay, and to determine whether or not I use the positive or negative, look at that m plus 3. So if it's an m plus 3, that means I have to flip my sign here. Okay, I have to, because I'm adding going downwards. Alright, So we drop the 6. And, well, we're going to do synthetic division. This is the factor theorem. Alright, it's in your notes what this thing does. So I'll explain it once we get there. That's negative 18. Add that, that's negative 6. That's positive 18. That would be a negative 5, which would be a positive 15. You get a 0. So if you get a 0, that means that m plus 3 fits into this polynomial evenly. There's no remainder. Okay, so if there's no remainder, it means that m plus 3 is a factor. So the answer is yes, he's a factor. Okay. Number 12, just to verify that again. Let's see, we got x plus 7, so that means that I would put a negative 7 in the window. 10, 78, 61, and 39. Okay, those guys do not have no need for spaces. So I drop it. So 10 drops, negative 70, that's 8. That's going to be negative 72, that would be 11. Negative 11, that would be a positive 77, and nope, it's all I have to think is it's not 0. Okay, I'm not even going to add it up, but I just know it's not 0. So with that then, I would say no, it does not go evenly. Alright, it is not a factor. I would have some type of remainder. And you can tell, I mean, that's very helpful when you are trying to find rational roots. Like, where does it hit the x-axis? Alright, so keep moving then. We're going to go ahead and do number 13, but you know what? I'm going to pause here as the video's gotten kind of long, so let's stop.